So this is lab 4 on k-means clustering in Spark. And the first 2 tasks are the lab. And task 3 is exercise. Here are some suggested readings that you should at least click, right, and see what it is. If you don't, even if you don't go through the details. The first task, right? The first task, I label it as critical, right? So I label it as critical, right? So because this is important, right? So and it is fundamental. As it is fundamental, it can greatly impact your work on Spark, right? So it is about space management and Spark configuration, right? So that is so far, actually, the data we have studied are all small, right? So small. But when you deal with bigger data, you need to make sure that you have enough disk space, right? So make sure you configure Spark properly so you have enough resources, right, available. Otherwise, you cannot run your program at all, right? So you're stuck. Okay. For space management, so here I give you instruction on how to move from request more memory and install matplotlib. And then here we move, right? We move from our usual working directory for at home to data, right? To data, because we have 100 gigabytes over here, right? So here, right? We under data, the username we have 100 gigabytes, but under home, right? So you have only 10 gigabytes, right? So therefore, you can follow the instructions to move our working directory to data, but still use the same file structure, right? So you can still use the same file structure, and you don't need to reinstall your environment, right? So it's it will be recognized, right? So you don't have to do the installation. You just need to change your work directory. Right? You don't need to reinstall the PySpark and so on. Right? There's no need. We are just changing our working directory. Right? Just changing our working directory. And you can check your disk space using this, right? So you can check your disk space so you know whether it is running out of space, right? See if it's 100% or 99, right? So it means you run out of space. Okay, so that is about space management. And for Spark configuration, right? So this is very important. And you should really take a look at this table. Right? So take a look at this table. Click here, right? So to look at the available configurations. And here are some good references. You can take a look. And you may notice that in the first Python file I provided, you can see config, right? So that is actually, we are configuring Spark, right? We're configuring what? We are configuring the local directory, right? Local directory, the default is temp. And we know there's problems. You will run out of space if you use that. Therefore, we have instructed you to use fast data, right? So which theoretically no limit, right? So so you can just use it, right? So this is for temporary, as a scratch space, right? So therefore, we have already configured Spark actually, right? So configure the local directory to fast data, right? So and you can check, right? You can in the Spark shell, you can check, right? You can check the configuration, right? So if you do that, that's all the customized, right? It's customized configuration, right? So if you see in the terminal, right? So it will the format is nice, right? So and you need to pay attention to the driver memory, right? To the driver memory and potential out of memory problem. You will meet it sooner or later, right? So you know that when we start the session in this lab, I have requested memory to be 10. We requested 10 gigabytes of memory, right? So we requested 10 gigabytes of memory. But there's another setting that you need to set, which is driver memory, right? So you can see, read over here. The default driver memory is only 1 GB, right? So even if you requested 10 GB, if you do not change this driver memory, they will still use the default of 1 GB of memory, right? So therefore, you need to change the setting if your computation needs a larger memory. If you have out of a memory problem, you need to increase your driver memory. Okay, so this is how you can set your driver memory when you submit a job. You can see Spark submit, you can specify the driver memory to be 8 GB. So this means AG means 8 GB. Okay, so that's it, right? So but this cannot be big, right? So you cannot exceed the amount of memory you have requested in the beginning, right? So over here, right? So if you just requested 10 GB, but if you here you configure it to be more than 10 gig, it doesn't work, right? Because you just the system just allocate 10 gig to you, right? So if you need more, you need to request more in the beginning. Right? You need to request more in the beginning. Okay. Right. So you can, this is an example, right? So of a previous example when we run really big data, right? So we have used this sample example of configuration, right? So you can see like how complex it can be when we want to configure it. Okay. And this is a reminder, right? It doesn't mean that you will just request a lot, right? So that you will never run out of resource. But the problem is that the more resources you request, the longer time you need to wait, right? So because because this is a shared resources, right? So they are shared resources. Okay. So the k-means clustering, I think it should be relatively simple, right? So it's not difficult. You just need to learn the API, which we have covered in the lecture. And here is a plot, right? So how do you plot on HPC, right? So, and this is a good way, right? So that you should really first, right, you need to import matplotlib and set the backend, right? So use AGG, right? So do this, and then you import, right? Then you can plot it into a figure. Okay, I think the example here is easy. It's just the fit stuff, and you can see the center. Right, so the transform. You see here is implemented as transform, right? So the cluster label, right, is considered as a prediction, right? So this is a feature example from PySpark, right? So they treat it as prediction, right? So that's why I'm saying that this is kind of classification without label data. And you can see it is considered as a prediction over there. Another very useful API is called summary, right? Model summary. And you can examine the summary of the model, including the training cost and so on. You can examine the k-means summary API, which is in Scala or Java, right? So it is in Java, right? So you can see the URL over there that's in Java. But you can just read the API, right? So you can learn the parameters and so on. And you can also learn another very useful trick is to save an algorithm, an estimator, and a model, right? So here we show you how to save the k-means, right? You can save the k-means, right? So this is basically an algorithm, an estimator, and you can save it, right? So in the temporary path, you can also save your model and load your model later, right? So then we move on to a real data example of the ARIS clustering. The ARIS data, right, is very old. It's almost 100 years old, right? So I think that is introduced by Fisher, right? By Fisher, who is a father of modern statistics, right? So he's very famous. He's also from UK, right? From the UK, and you can read about him, right? He's very famous and a very important man in the history of statistics and machine learning. Okay, that's a small data set, right? You can try to use describe to see the statistics. Well, here, this is the same as previously, right? So the transformation thing, you transform the individual feature vectors into features into a feature vector. And then we show an example of determine K, right? Using silhouette analysis, right? So we have plotted two versions. One is against the cost, that is SSE, and another is plot versus silhouette. They are, none of them are perfect, right? They all have bias. Right? So they all have bias. So there's no ideal solution, right? So okay, so these are the some very simple, I hope, right? So it will look simple to you exercise, right? So I have only said 2 questions. And there are many interesting applications, right? So for customer value analysis, finance or business application, and network infusion and collaboration, right? So that's all, right? So that's all for k-means clustering, and this is our 4th session in scalable machine learning, right? So the next session will be my last session on PCA. Okay, I will see you in the next session. Okay, next week. Bye bye.